Welcome to the 20th section of the course of Expert System with C++ and Qt. My name is Carlos, and now we're going to have a quick explanation of what is Modus Ponens and Modus Tollens. As we mentioned previously in previous videos, inference kernel gives meaning to the rules, and not only that, it also establishes implicit knowledge. To explain what we mean with implicit knowledge, let's have an example regarding to our expert system. Our expert system will detect why it's not working in our car and let us know how to solve it. Imagine that your car stops in high revolution and there is a lot of black smoke. Consider that situation. Stopping in high revolution and presence of black smoke is implicit knowledge. It's physical and real for the customer perception. But what I mean with implicit knowledge is the technician knowledge who we attend for help. Usually we give him the symptoms and he might know what can be the reason of the failure by experience. But not only that, this kind of errors are not straightforward. Usually they are not that straightforward. He might need to test the vehicle in some way and infer again what is wrong with the car. So in this case, the implicit knowledge is the experience of the technician. Okay? Making clear what it means implicit knowledge, let's move what is the concept of modus ponens. Modus ponens is a Latin name for a propositional operation called implies elimination. Actually, it's not a operation, it's a rule. This rule states that given phi, and knowing that phi implies c, we might rightfully conclude c. So, let's give an example. If the car stops in high revolution, implies or means that there is a problem with the injection system. Or another example, if the car has black smoke, means that the gasoline is not burned correctly. Okay. Now, after that there is modus ponens, there is an hybrid of the implies elimination, which has the name of Latin name modus tollens. Suppose that phi implies c, and we have the case that phi is false. Thus, we have that c and negation c is impossible in this situation. Then we might infer that phi must be false, or meaning that phi is the negation of phi is true in this case. So for example, if the combustion is good in high revolution situation, but the high revolution situation is not working, then the combustion is not good. Or for example, if the car has black smoke, means that the gasoline is not burned correctly. But if the gasoline is not burned correctly, it means that the car has problems of the combustion. Okay. In this case, we are having two rules that infers to the same conclusion. This conclusion is that the combustion is not good. Or we can even use this implicit knowledge to the next rule as explicit knowledge to try to infer another rules until reach to a certain solution. So the technician can determine that the combustion is not good, and then by experience try another test, such as change the spark plug or clean the injectors, and maybe then the problem will remain not solved. So we can use this last notes as implicit knowledge to the next draft of test and determine new conclusion. So this is the end of the video. In the next one we will learn about how to create a knowledge base of system models using specific structures, rules. Share, unvote, and comment in the video, and have a look to our website GearTech. Thanks.